So, hi everybody. I'm William Molinari, and I'll talk about the open source behind the web requests. First thing is, I'm Brazilian, so I'm not a native English speaker. Then we tend to destroy everyone's games on the internet. So that's it. We have a lot of Brazilians here, by the way. So we would conquer the world sometime. And I have 100 plus slides, and I have just 30 minutes to say everything. So that will be fast. Yeah, I tend to speak fast. So sit tight, and let's go. We have some water here, and I'll need it. I'm William Molinari. I'm also known by this weird nickname called Potex. Yeah, that's something from Diablo 2 and some 10 years ago. I work for LocalWeb, so thanks LocalWeb for having me here. They're paying the expenses from Brazil to Brussels. I'm also the main organizer for São Paulo Ruby Users Group in Brazil. It's the biggest Ruby user group in Brazil with meetings. It's a kind of cool thing. And I tend to do HTML5 game development in my spare time just for fun, so you can check it out if you want to. That's it about me. Let's go to the motivation about this presentation. And the main motivation is that I wrote a book about that in Brazilian Portuguese. So yeah, it will not be so useful for you, but I tend to translate. I want to translate that to English in the future. So just tell me if you want that, if you think that is a good idea. But the book is about what happens in a web request, a lot of things that is happening from the operating system and networking and, I don't know, server frameworks and that kind of things. And so I'll focus on the desktop part and not going so deep on server side. But that's it. So let's start with our user. I'm a big fan of J.R.R. Tolkien. Yeah, I'm using some T-shirt of Gondor, and I'm using a lot of his characters for that. So let's imagine Gandalf as a user, and he's trying to access my personal blog. I don't know why, but he's trying to do that. So the first thing that will happen, we'll use a browser, of course, and we use Chromium in this case. So it's the first open source software here. And the first thing is to type an URL there. And the first question that Chromium will ask is it really an URL? And it may look silly, right? But why we will not ask type an URL in the address bar? And you know that you can type wherever you want in the address bar, and it will just search on a search engine for you. In this case, it will use Google to search for this BR, you know. But we will assume that that's an URL, and we can continue to the next question. That is it in the HSTS list? And by HSTS, I mean strict transport security. That Chromium has a hard-coded version of a list of websites that can be accessed via HTTPS. Firstly, so it will ask that if your URL is present on this list, and every server can send a strict transport security header, so it will be included there. It's dynamic. So there's a lot of links here, so it's a link for Chromium if you want to look to it. In this case, we'll continue with HTTP for a while. The next question is, does it have cache about that? And we will assume in this presentation that there's no cache anywhere, because it will be so easy, right? Just return the cache and thank you. But so we'll continue without caching. So in this case, there's no caching, so browser just continue. Caching can be done via expires or cache control or e-tags, a lot of HTTP headers here. So there's no cache, we can continue, and browser will split the URL into 3 different parts: protocol, domain, and path. We have to continue through domain because the internet doesn't know what this potex.com is really mean, right? We have to use IP addresses and this kind of thing. So we have to get the IP address for potex.com. It will check if we have a DNS caching for that. So Chromium has its own version of own implementation of DNS. You can check into Architecture of Open Source Applications book. There's a chapter about that. So Chromium has its own implementation of DNS, so it can go faster. But we will not continue with that. We will use get_addr_info. There are 2 main implementations, with internal implementation and get_addr_info using the operating system. So we will use get_addr_info so we can get into the operating system right now. So by operating system, I mean POSIX and glibc, right? That's GNU libc. So glibc will look to your etc hosts. So you may have defined your just like a DNS in your etc host. So you have this domain points to a different IP address. So it will not go to the real DNS, so it will just use your etc host. There's a link for the implementation if you want to look to it. So that's get ADDR info. That's it. I'm not going to deep dive on the code because it's boring. You have that on the presentation. So what get ADDR info will do is to firstly is search on ask name server's caching daemon. So in case you have this is another layer of caching, so you may have a cache for the domain resolution, so it will ask name server caching daemon. Obviously, we are not using cache in this case as well. So the big picture is we have a user. We are getting to the operating system to live to the internet, right? But to live to the internet, we will have to go a little further to a little bit of theory to Aussie model. And I don't know about you, but every time I talk about the Aussie model, I get one of those caps in my head because it's so academic, right? It's so boring to talk about that. So let's try to simplify this a little bit to not be so boring. Let's remove those two layers there, and we use just 5 layers here. So we can split that into the operating system and the user part. So we have application for the user and those other 4 layers for the operating system. So we can see that as protocols, and we will look through each of those protocols one by one. So let's get started with DNS. As I said, just a parenthesis here, Chromium has its own implementation of DNS. You can check it out if you want. This is the link for the Chromium source code. And getting back to the get ADDR info, we have 2 syscalls here, a call for socket and a call for connect. There's the source code. So we are using UDP IP, socket dgram from UDP, and IP proto from IP. We are using UDP IP and just attributing an IP address via connect. So the connector will just get this IP address and attribute to the socket. So we can check that with strace if you want. Don't worry about this whole code. Chromium has a lot of process for rendering, for tabs, for extensions, for a lot of things. So I'm just getting all the PIDs there. Let's focus on the strace there. So we have -F to get all the threads, and we just using some syscalls there that socket connect. So what we have here, we have a socket for IPv6 with UDP IP. So we are trying UDP IP version, trying to get an UDP IP, trying to get the IP via IPv6, sorry. So we're trying to do a connect, and I don't have IPv6 configured in this laptop, so network is unreachable. So it tries IPv4, PF IPNet with UDP IP to get the DNS. We can see that we have here IPv6 for Google DNS and IPv6 for Google domain resolution from IPv4 and IPv6. So we get UDP IP, and we get the IP from my personal blog, and so we get the data that we want. So, but why he's trying IPv4 and IPv6? I didn't ask for that, and the reason is that we have this algorithm called Happy Eyeballs working behind the scenes, and we have the RFC for you. Who don't want to read an RFC on this Sunday, right? It's so cool. So that's it if you want to read it. But what Happy Eyeballs does is just request both entries in the DNS. So we have A and for A's, IPv4 and IPv6. And so you can do a request for both applications, IPv4 and IPv6. And you just use IPv4 in case IPv6 is not working, or just use IPv6 if it's working. And why we need that? We are still using that, but we don't know. It's because we are trying to transition from IPv4 to IPv6, right? And it's not all IPv6 connections are fully working. So we are doing that to use it when it's available. So we are not penalizing our user because of that. So that's it. Happy Eyeballs is helping us. Curl implements that. Firefox, Chromium, a lot of the new Macs implement that. iOS. So that's it. It's working. So let's get to the UDP IP in this case. We are in the DNS yet. We are not to the HTTP yet. So UDP is implemented inside the Linux kernel. So this is the operating system, right? UDP is implemented inside the Linux kernel. I'm not a kernel hacker, so I'm not sure if what is happening there. But this is the first file that you can look if you want to understand some things. And what is happening with UDP is that we just attribute an IP address and send it to the internet, and you will not you don't know if you will receive a response and a confirmation about that. So that's UDP. We'll get to TCP soon. So that's it. We can finally go to the physical layer, but let's let it for some time from here soon. So the DNS, I did this with DNS tracer. So what's happening with DNS here with domain resolution? We are this user. We will ask our recursive name server. In this case, in my case, it's my personal router at home. So there's no cache. Remember that there's no cache. It will ask one of those 13 root servers that will send us the IP for one of those 2 top-level domain servers. In my case, POTX.com is the top-level domain for .com. That I'll get my authoritative server, and I finally get my IP address. That's the 192 up there. So that's it. We finally got what we were looking for. That is my IP address, and we finally can get to the HTTP. That is what we were looking for. So let's get started from scratch. So we have TCP/IP with HTTP now. And let's get started with TCP first, because it will be better to explain. So yeah, TCP is implemented inside the Linux kernel. So if you can look to the TCP/C if you want to. And TCP is really different than UDP, right? You have a lot of control and statuses, and yeah, we have a connection here, not just sending a text. But we will not go into detail of that because it's boring, right? So let's look to the three-way handshake and how we establish a connection. So we'll use Gandalf again for this case. What's happening here is that we have a server listening on the other side, on port 80, for example. My blog is running port 80. So Gandalf in this case is the operating system. We'll send a sync package to the server. This is the first step. So it tries to connect to the server, and the server says, "Nice. I was expecting a connection. I want to connect to you as well." So it sends a ACK to confirmation as a confirmation and send to the other side. So this is the second step. And as a third step, it just confirms. So we have a connection from Gandalf to the server and from server to Gandalf. So it's a fully established connection, and we have Gandalf happy, right? Yeah, that's it. So now that we have a connection, we can go to HTTP and HTTPS. We'll start with HTTPS because we have to have an encrypted connection here. So HTTPS is just HTTP over TLS. So we have an encryption tunnel between quotes here. So it's just like that, just like between HTTP and TCP/IP. It's based on this article. It's a dense article if you want to read it. Okay, let's imagine that we already have a connection here. You can remember that's Gandalf happy. The first thing to do is to send a list of ciphers and a URL from client to server. And by a list of ciphers, I mean the thing. You can check your ciphers if you go to this website. But there's a lot of encryption algorithms and key exchange algorithms, and yeah, that's it. A lot of things that we are not going in deep detail here. So the server will pick one of those ciphers and send back with the certificate. So in this case, we're using TLS, RCA with RC4, and yeah, that's it. And what we can remove from that is that we'll use RSA for asymmetric cryptography, RC4 for symmetric cryptography, and MD5 for hashing. So we use the public key and private key here to exchange the key. Symmetric cryptography, we use this key to exchange information, and we will use hashing just to compare packages and see if everything is okay. So that's it. Just a second. That awkward moment. Okay, so we will check the certificate. Because certificate is solving a trust problem, right? We don't know if this guy is POTX.com for sure. So we are asking a third-party guy if he is really POTX.com, and the certificate solves this problem. We will just check the sign of the certification with one of those public keys that we have on our my laptop, for example. And if we sign in, the sign is the same as the third party that's signing with the private key, we can be sure that this guy is really POTX.com in case we trust on a third party there. That may be, I don't know, VeriSign or Let's Encrypt, and I don't know. So we will check if we have a trustworthy CA certificate authority. We will look for a valid date in case the certificate is not expired. Expected URL, and we will have to check if the certificate is still valid. So we will have those checks. And so we can do a master key exchange. And there's a complicated process going on here. I'm not going into detail, but there's a random numbers going from one side to another, and a lot of I don't know, cryptography. Those algorithms will go in action here, so we are not going so deep here. But there's a big key on both sides that they are generated on a secure way. So finally, they have a trustworthy connection here, and it will use RC4 as symmetric cryptography, just like your, I don't know if this is a good explanation, but just like your Wi-Fi, you have a big key and they use symmetric cryptography for that. And MD5 for content verifying, so every package will be verified with MD5. In this case, right, in this cipher that we chose. So that's it. Now we finally have TCP as a connection and TLS as an encryption connection as well. So we can use HTTP or HTTP2. HTTP2 is the best one, I think. I would recommend you to use HTTP. HTTP2 is really, really cool and is the future. But we use HTTP just as an example because it's plain text and it's easy to show there. There's a link for the Chromium implementation for HTTP and HTTP2 that's called Speedy on Chromium coding if you want to look at it. Okay, so this is HTTP. There's no rocket science here, right? It's just a get here and with the file that we want and the protocol number, name and number. And we are using host here just because I'm using GitHub page for this case. They may have a load balancer and you'll have to use that. But that's it. There's no rocket science. That's HTTP. And so we finally have that, and we go out to the internet. So we use Ethernet or Wi-Fi, and they have the physical layer. I'm just that's not exactly like that, but we'll have those two layers down there. So it's based on a paper. So that's it. But let's go inside the Linux kernel between quotes. So we have a socket library there, just like glibc, for example, that will talk to the TCP/IP stack inside Linux kernel, that will talk to the frameworks and drivers developed there, so we can finally go to the hardware to leave the operating system, the machine, by the way. So this is the paper I talked on the left side, so if you want, you can read it if you want. So we are going to kernel on IPv4 TCP/C. There's some frameworks to develop device drivers for wireless and net. And we have IWL Wi-Fi that is the driver for this laptop. And the only part that is not open source here is the firmware on the Intel firmware. So that's it. It's a blob. So everything else is open source. So we're finally leaving the operating system, and we will go to our router to the internet. I'm not talking about the router because I will not have enough time for that. But let's go to the internet, and by internet I mean just a trace route because there's a lot of devices out there and we can't study that. So let's imagine a trace route with TCP because we lost a lot of packages if you use UDP here. So that's it. I'm going to my router that is Palantir. Yeah, it's another thing from Lord of the Rings. Yeah. So we're going to Virtua, that is Brazilian ISP. We're going to the backbone that go to New York City, probably NYK. It's going to USA backbone and GitHub pages in this case. That's my personal blog. So that's it. Let's imagine that's the internet, right? Just like IT Crowd, just that little box. Yeah, that's the internet. So I'm not focusing on this part, the server part, because we are in the desktop that room. So I removed a lot of slides here. I was studying framework, studying a lot of things here. So I just removed that. So let's imagine Nginx. Nginx may have a configuration for Unix sockets and for TCP. So in this case, it's for TCP, and this case is for Unix sockets. So you can check the documentation. And we imagine that Nginx is talking to a web application server. So we are talking via TCP to this application server. We can use TCP or Unix socket. In this case, we just chose TCP because of reason, right? So we'll just use that. So Unicorn will talk to Rack, that will talk to Rails. In this case, it's just a Rails setup, right? We don't have to be familiar with Rails. But what Rack does is just to make the protocol between Unicorn and the Rails app. So you can change your framework to Sinatra, I don't know, and your Unicorn to, I don't know, Puma, and you keep the same protocol there. So this is why Rack exists in this case. Another good question here is that why I have to put a web server on, instead of just using Unicorn, a web application server to the internet. And the reason is that Unicorn is well prepared for that. Nginx is well prepared for that. Unicorn is just implementing HTTP, but it's not so, I don't know, it's not a good guy to be on the internet. Because, you know, internet is difficult. We have a lot of Brazilians there. So what Rails will receive here is just a Ruby hash with a lot of things here. We have CGI 1.1 there. We have, I don't know, this is what type of localhost, so I was testing here. HTTP 1.1, WebRig, that's the web server, application server. That's it. So we have a lot of things here. And Rails will receive that, and we'll try to understand what we want with this URL. So we will try to understand what is a controller and what is a model, what is a controller and what is a view. So that's it. Let's imagine the MVC here. I would change a little bit just to get the routes controller. So we get some data from model, build a view, and we'll have an HTML here. So this is my personal blog finally. So we can finally get all the way back until combo breaker, until we get to the user. So we will not get to the user right now because it's just plain text, right? We don't want to show plain text to our user. I don't want to, I don't know, understand HTML for that. So that's it. That's that time when you have a spinner there in your browser is just receiving a lot of information that is HTML, and it will have to parse that and build the web page. So here is where the CS algorithms that we learn in the university comes to life, right? Because we have to build the DOM tree, that's document object model tree, so based on a lot of text there. And so there's a link for the implementation for inside Chromium and inside Blink, that is the rendering engine for Chrome. So that's it. Chromium will receive your HTML and fix a lot of errors for you. So I don't know about you, but I never saw HTML syntax error. You can't see your Facebook comments because there is a HTML syntax error. That does not exist, right? And that does not exist because browser is doing a lot of magic for you. So that's it. Thanks, browser. We had more black magic in the past when we have IE6. You know, it's more magic than we wanted. Just like Gandalf in The Hobbit and Lord of the... Yeah, okay. So we have a lot of tags here. So we are receiving images and scripts and CSS and this kind of thing. So browser will start downloading that. Every image and every link will be downloaded in a different thread. By thread, I mean asynchronously. So that's being downloaded asynchronously. And every time it finds a JS file, it will be downloaded synchronously. So it will block your whole rendering and download the file, execute it, and so it will continue. So that's why you have to put your JS file at the end of the page. So that's the reason. And just remember that every one of those guys is a Gandalf happy thing. Yeah. So you'll have a lot of I don't know, three-way handshake and TLS thing. I know that's keep alive to save the day, but in theory you have a lot of things going on here. So that's it. And by using HTTP2, you will just use one connection and multiplexing through this connection. So use HTTP2 is the future. So we'll have to do the same thing with CSS. So we have the DOM tree and the CSS on tree. So we have to do the same thing. There's not just text. We have to create this tree. And so we have those two trees, and we have to merge them. So when we merge those two trees, we will have the render tree. And based on a render tree, we can finally build the whole application, website in this case. So there's a good article about that. That's a master thesis, I think. So just read it if you want. And that's really interesting. So you'll find a render tree, and this render tree will have X and Y, so you have to draw this box with X 100 and Y 100, so your browser will keep printing that on your display. So finally, we finally have Gandalf in this case. We finally have my personal blog, so I can read about Go and Ruby. I don't know. So that's it. And as a summary, is that open source powers the web. We have a lot of open source software out there, and that's why we have not that's why, but it's powering the web. It's really cool. And yeah, that's it. It's really easy, right? Okay, so I hope you enjoyed this presentation and it helped you to understand what's happening on a web request through open source software. And I'll be waiting for a question if we have time for that. And thank you. That was fast.